Hi, my name is Kevin Cavell and I'm a product manager at Keysight Technologies. Today I'd like to show you how to evaluate quick charge technology with our N6705B DC power analyzer mainframe and our new N6785A higher power SMU. Our setup consists of the mainframe along with the 85A module installed in output 3, and in output 1 we have an 81A SMU module, which is one of our lower power, up to 3 amps, where the 81 is measuring the current from our charger, and the 85 on channel 3 is measuring the current that's coming from the battery. So the battery is actually powering our phone. We also have some software, the 14585A software, that's connected to the DC power analyzer in order to do our analysis. So we're going to be looking at quick charge technology today. So let's take a look at the software and see what we can learn about that technology.
This is the 14585A control and analysis software for advanced power supplies. On the left side we can see our instrument control flyout window, and it gives us a representation of the front panel of the N6705B DC power analyzer. Again, we're going to be using output 1. It's an N6781A SMU module to measure the voltage and the current on the USB charger. The voltage is actually being measured by the auxiliary input that is on the N6781A and on the N6785A only. For output 3, we're measuring the voltage of the battery and the current of the battery. So if we want to make a long-term measurement, we want to use the data logger. And we can make the screen a little bit bigger by closing the instrument control flyout. I've set this up already, but it sets up pretty easily, just like a scope. We have 20 seconds per division. We're going to have a measurement of 3 minutes. All of our data is going to be saved to this data log file. And all we need to do to start our measurement, to start the data log, is press the data log play button. So let's do that. When I do that, we'll see a strip chart of measurements starting on the right side of the screen. Our voltage for our USB is up at 5 volts. The current is down at 0. The voltage for our battery is up at roughly 3.8 volts. And the current is also down at 0 because the phone is off. And the USB charger is not plugged into the phone. If we wanted to get the exact measurements, all we need to do is grab one of the markers and drag it onto the waveforms, and down at the left, marker 1, you get all the exact measurements at that particular point. So 5 volts, 1.3 microamps, probably just a little bit of leakage current, and 3.8 volts and about 186 microamps, also probably a little bit of leakage current that's occurring with the phone. Okay, so let's turn the phone on and we'll see some current consumption by the phone as it boots up. So when I do that, I press the power on button. You can see the current comes up. The battery is powering the phone at this point. Again, if we want to get some information on a particular point, we can drag the marker over and we can see that the battery voltage is 3.8 volts and about 400 milliamps at that particular moment. If we want to get an average, we can pull over the other marker, and the average between that point is in the center. 1.8 amps is the average as it's booting. Okay, so you can see the voltage of the battery is a bit low. Fully charged is around 4.2 volts for a lithium-ion battery. So let's plug in the charger and see what happens. One other thing to note is here the current has gone down, almost back down to very low value. If we drag the marker over, you can see at that particular point it's about 50 milliamps. That's because the display of the phone went off. So let's plug the charger in and see what happens. Alright, the charger's been plugged in, and we can see that the current for the USB charger has bumped up. The current for the battery has actually gone negative as it is being charged by the USB charger. It's gone off the screen. But one interesting thing to note about the USB charger is this level here is 5 volts. But once we plugged it in, after a short period of time here, the voltage actually went up to 9 volts. So that's, if you look at marker 2 down here, it's 9 volts. Marker 1, 5 volts. That's the quick charge technology. And this short period of time, while it was still 5 volts and not 9, is the negotiation between the phone and the charger. They're talking to each other and letting each other know that they're both quick charge technology capable. Then the USB charger actually ups its voltage to 9 volts to provide more power to the phone. And inside the phone, the quick charge technology is taking that 9 volts and converting it down to 4.2 to charge the battery. And in that process, the current is increased for the charge. As you can see, if we move the charger, the marker, over some of the negative current here, you can see it's minus 2.7 amps. And that's negative because it's flowing into the battery as it's being charged. So this is really great to visualize what's happening. Everything on the screen is shown synchronized in time. You can see and get a measurement of how long it took for the negotiation between the phone and the charger. Roughly, if you look at here, between 1 and 2, the delta is about 1.3 seconds for that negotiation to occur. And then if you want to get some average measurements of how much current is being drawn, on average about 2.4 amps to charge the battery. Again, you can move the markers around to get whatever measurement you like, whatever area you have a particular interest in. And it's all easily done. You can even save this and load it later for post-processing at a later date. And again, the N6785A is really great for this because currents will increase over 3 amps, and our older SMU, the N6781A, could only go up to 3. So it wouldn't have been able to do the measurements for this new quick charging technology. So again, this is the 14585A control and analysis software for advanced power supplies, and we were looking at quick charge technology.
So we saw with this solution that the phone will negotiate with the charger, letting it know that its battery is low and that a faster level of charge is necessary. We got to see everything synchronized in time using the data logger built into the 14585A software, along with the DC Powerlyzer and our new N6785A SMU that allows testing up to 8 amps. Again, without this newer solution, you wouldn't be able to test something like quick charging because it goes above 3 amps, which was a limitation on our old solution. Be sure to check out all our other videos online, and thank you very much for watching.